Welcome back to the shop, guys. I've got a pretty interesting project in front of you right here. This is going to be a bit of a challenging repair, I think, going into this. So this belongs to one of my viewers. His name is Jack out of Texas, and he is restoring or repairing or fixing up a Induma milling machine, and this is part of the power feed on the milling machine on the x-axis there. He says it's a Norton gearbox, and it's a pretty big, massive gearbox with an electric motor mounted on it. It seems quite enormous for what this thing is being used for. I'm not familiar with that machine or these components, but it seems that they were very ruggedly built, very heavy duty. A lot of cast iron in this, a lot of weight. But this piece is broken, and he emailed me, showed it to me, and asked if this was something that I would be interested in helping him fix. And I said, yep, I think we might be able to do this, so go ahead and send it on, and we're going to go ahead and see if we can tackle this job. So let me show you what the problem is. I've already got, this is the top of the unit, by the way. You can see this mounts to the end of the milling machine table, so your table's here, and your power feed is all up underneath this. So I got these 3 bolts out. You can take this cover plate off. And the problem is, you might be able to see there, right up inside here, well, it's cracked. And it's cracked all the way through and all the way around, from one side to the other. And you can see where somebody in the past has attempted to repair it. It looks like they have brazed it on this side right here. There's some in the middle there, but I can tell that looks like that might have been done with a TIG welder. It was a pretty weak attempt at trying to fill that in, but they didn't get very far, and it looks like they quit. And then there's a little bit here, and then you got some right there as well. So it's actually still being held together by the weld, but it will move. I can actually make this thing kind of move back and forth from the weld. I think there's still some of this weld in the center right here that's holding. So I think this was probably done by a TIG braze. I think that was the method that was used. So you can see part of the problem with this repair is that the crack goes right through all of these mounting holes right here. So you've got 2 holes here. This is a tapped hole here. There's this bolt and spacer screws in right there. And then I believe these are going to be mounting bolts that probably hold the bottom portion of the gearbox onto this top portion here. So like I said, I think it's going to be quite a challenge to get this thing fixed. You know, it's one thing to weld up or braze up a crack, but when you've got a component that's as complicated as this, I mean, this isn't something that you're going to replace unless somebody just happens to have this laying around that they're not using. But probably very difficult to find this component. But saying that, if you do have this part, if you're seeing this video and you have this part, please send me an email, and I will forward that over to Jack and let him know that maybe there is a replacement part out there in the event that my repair fails and doesn't work. I'm going to give this every attempt to give him a solid repair, and hopefully this will work and go back together and function like it should. He did say that he is planning on fabricating some kind of steel bracket to mount to the gearbox and support it off the table to help reduce some of the strain that's going to be pulling on this cracked area right there. So he'll do that himself, and maybe that'll help that thing out. So my plan of attack, let's go ahead and talk about what we're going to do. I do plan on separating this into 2 halves, and my plan is to braze it, and I want to braze this entire joint completely up. So we're going to be eliminating the holes. We're going to be cutting this section out. I'm going to be filling the holes up completely with brazed material. We'll V this out really good, get in there. This will hopefully be brazed in nicely. This hole is going to be completely filled in. I'm going to go ahead and cut this section of this ear off right here where this tapped hole is, and I'm just going to build that up with braze, and then we will just shape that back. We'll probably just use some air grinders to shape it, and then we'll obviously have to do some milling on this surface right here, and this surface right here to kind of get it flat, back flat again. And once we get it all brazed together, I'll have to set it back up in the mill and remachine these 3 holes right there. So, mill it and drill those holes, drill and tap these holes right there. My plan is to use a fixture plate. So that's what I've got the part sitting on here. This is a piece of 1 inch by 5 inch flat bar that I cut off. And we are going to use this as a fixture plate. And this will also, it'll go on my shelf and it can be used for any other fixture plate needs in the future. I'm going to drill and tap the hole pattern that you see with these 2 holes and these 2 holes here. I actually, it's 5/16, so I've got these 5/16 cap head bolts, and we will be able to bolt this guy down to this fixture plate and hold it while I at least get this side of the casting brazed back together. And then hopefully that's going to hold it nice and square. Once I finish this side and let it cool, we will remove it from the fixture and then go ahead and flip it over and start working on this side and finishing it completely up. Of course, we're going to have to, machine this right here. I'm hoping that I can get this so that it stays completely flat and straight and true. Maybe at a very minimum have to do a very light skim right across there just to clean that up. So that's why I'm saying this is going to be a bit of a challenge, but hopefully we can tackle it and get this done and give Jack a solid repair on this part. So I think that's it. Let's go ahead and jump into it and get started. We will begin with getting our fixture plate made, and then we will move on to start getting this piece separated and ground and ready for brazing. I want to show you guys this pretty cool chamfering tool that I recently got from KBC Tools. I've been playing around with it, trying to get familiar with using it, and I think it works pretty well for what it was designed to. So this is just it's a standard like little angle grinder, and what they have done is that they've got a couple of triangular shaped inserts in there, carbide inserts, and they got this ball bearing on there. So it works kind of like a router, if you will. This flange piece here is what kind of guides it against your surface. It's adjustable. You got some graduated marks there, and I've got it adjusted. You loosen the 2 set screws there on this flange, and this piece just turns in or out. It screws onto the body there, which will create more depth or less depth, however you want it set. So you got quite a bit of adjustment there to kind of set it up for your needs. So you can take pieces of material like this. This is the fixture plate we're going to make, and then you can go along these edges, especially like when you have these cut edges that are real sharp. You can take this guy and just run it right across that edge and cut a nice little chamfer on there. So wanted to show that to you. Like I said, I've just recently got it, so I've been playing around with it. You do have a speed adjustment on there if you need to adjust the speed. And there's the part number for it right there, I believe, 1-829-1305. Comes with the 2 wrenches there, the book. And they did say that these ball bearings here that go on there, they do stock the bearings and the carbide inserts. So if you happen to, they just said be careful with this, because if you drop this thing and it lands on that, it is going to break that bearing or mess it up. So they do stock the bearings and the 2 carbide inserts that are in there as well. All right, so we'll go ahead and I'll show you how it works on this fixture plate we're going to make. Don't forget your earplugs. This thing is kind of loud. I found that if you kind of hold it down, you don't have to worry about anything cutting your fingers here, but if you kind of hold it square against your piece, you'll get a little bit more of an even cut on here. I didn't get it quite even on that side there. That's it. Just a nice little chamfer. I think once you get efficient at using this little tool, it can be a real time saver. Pretty cool. Works pretty good. I'm going to go ahead and do this other side there as well. There we go. The little pneumatic deburring tool from KBC Tools. Nothing complicated here. We've got the fixture plate cleaned up. I'm just going to go ahead and get the 4-hole pattern drilled. I went ahead and measured everything out, and I've got my coordinates here written down for the 4 outside hole pattern. Just when you thought everything was going to flow together just perfectly, you go and you make a bonehead move. And just showing you guys that I screw up just like everybody else. What had happened here was this center distance here is different than these bolts right there. And I even had them written down, but whenever I grabbed my notes, I was only looking at the center distance on these holes, and I forgot that these were actually slightly off a little bit. So I made the hole pattern symmetrical to this right there. So even though they're lined up this way, they're actually a little bit too further in. So I've got to re-drill, re-tap, and all we'll do, I'm glad I made it bigger than I needed. So I'll just offset it to one side a little bit and re-drill and tap it with the proper bolt pattern so I can get all 4 of these mounted in there. I'm not going to show you that because it's identical to what I just showed there, but you know, just goes to show that it's really easy to make a mistake. And you know, I make them myself quite a bit around here, and as embarrassing it is to have to admit that, it happens. And I wanted to show that, because if I didn't tell you that, you would see, you know, 4 more holes tapped in there later on when we go to put this thing together. So I'm going to go take care of that, and then hopefully once that's done, you're going to get back on this guy right here, getting our prepping done for the Braze. After reading the notes properly, we finally have the correct bolt pattern drilled and tapped in our plate there. You can see we've got all 4 of our socket head bolts. So it's lined up good. This is going to provide a nice fixture to get in here and do the brazing on this side right there. And as well, whenever we're through with all the brazing, hopefully be able to use this fixture again to mount it down and do the milling and the drilling up here on this side. We'll have to take care of the bottom side first. We'll do that and then use the fixture plate to mount it down. All right, so from here I got to start getting this thing prepped for our braze. I've got this set back up. The 2 holes that we have to fill up, I'm going to run through there with 1 size larger drill bit, and with hopes that whenever we braze that and go back to machine it, that hopefully whenever I'm going down through there, we're going to be going down through the center of all of the bronze material instead of trying to cut into the where the original hole is at.
Should be 1 inch 562. Looks like it's in the center.
That'll give us some clean material there to fill in with the brazing rod. A little better look at what I'm doing. Just widen out that one side, cut it out and widen it out. So that's the drilled hole that you're seeing there with the crack going through it. Counterboard and a drill hole. So all that'll be filled up. So most all this is going to have to be removed for me to get in there and fill that hole in, just like, well, attempt to fill it in like we did that side there. So I'm going to have to make this side look like that. We're going to cut in there deeper and remove more of that original cast out of there. See them sparks? That means that wasn't like a bronze material they used. I don't know what they used. Got to get this side next. I'm at a point where I think I'm going to go ahead and try to crack this thing apart. It's just being held right here by what was left of this weld. That way I can get in here a little easier and V this section out and grind all this, whatever this material is in there that they used. I'm thinking it's some kind of stainless, but I'm not sure. You know, it's sparking, so it's definitely not a brazing rod. And I think what we're going to end up doing is, you know, we'll get this thing bolted down to the fixture, and I'm going to try to do a bunch of this outside area brazing. Once we get, let's say, the sides and the top brazed, we'll let it cool, take it off the fixture, and then flip it over and go in there and finish grinding out that V, and then braze in the bottom side. That's kind of my plan of attack anyway. So let's, there was a couple of the pieces that I cut out right there. That was it. You can see the crack has actually been in there for quite some time because it's real dirty, real cruddy up in there. Yeah, this is going to allow me to a little more easily get in there and prep all of this for brazing. I'll leave just enough so that we have a solid footprint that matches whenever we go to, you know, bolt it back together. It'll fit in the original crack just a little bit, and then flip it over once we weld the top. Go in there with our grinder and just kind of finish grinding this out some, and then braze that in. I think I got most of the grinding done to the point where I'm going to go ahead and get this thing bolted together and start brazing in the top side of this right there, start getting some of the side filled in. I ended up having to remove a lot more of this center section that I wanted to, but there was a lot of weld material in there whenever I was grinding that out, and there was a lot of contaminated cast iron that was real hard and chipping out, and then that whatever that filler material was in there. So I just went ahead and just tried to grind all that out, and so this will just be filled up with the brazing rods. Just fill that whole valley up, start filling in these holes over here, and getting the sides filled up, and I'll end up having to take it off of the fixture to completely finish brazing in those sides like that. And then once we do the sides, of course, we'll flip it over, and I'll touch up the bottom. This is where I was thinking, after we do the top and the sides, I'll probably come in here with what's left of these cracks and grind those out some until I, you know, reach the filler material, and then finish brazing that up with the goal of trying to have a 100% brazed joint all the way through there, all the way through the crack. So that's the plan anyway. I don't know if it's going to work out that way, but that's what I'm hoping that I can pull off. It's going to be a tricky one to do. There's a lot of deep areas in there to try to fill up. So I'm going to get everything set up and get started on this brazing here. I believe we got it ready to start our brazing. I went ahead and opened up this side a little bit more right here. This is where the ear is going to be. It just didn't look like there was going to be enough room to be able to get the torch and the brazing rod in there. Just want to give yourself enough clearance to try to get in there and build that up, and then we can always reshape all that back. But I was going to show you what we're doing. So I got this tip from Western Cast Repair. I've been talking with him over on Instagram, showing him some pictures. He is a pro when it comes to brazing. Cast iron, he does this kind of stuff every day, all day. He's got a lot of this kind of stuff under his belt. And when I showed him the picture, he suggested that I shim underneath the weld zone here where the crack is. And he was in agreement with me with my idea of putting this together on a fixture like this and bolting it down. And he says with the shim there, I got a 10,000 shim there, so it's got a little bit of a bow, right? That once we weld this top, it's going to try to draw it out a little bit. And he says after you braze the top in, go ahead and loosen the bolts and let it relax. It's probably going to pull that out just a little bit there. So that's why we're going to be going with the shim. So I'm going to use a C-clamp to actually, I need to use the C-clamp to get it to kind of pull all the way up to the crack. And then the bolts here will be used to hold it all down to the fixture plate. All right, so we're going to get it ready to go. Get started brazing on this guy. I'm going to start getting it preheated. I'm going to use this number 9 tip for that and just try to get everything nice and hot, and then I'm going to switch over to the other tip that I'm going to be using for the brazing there. loose it up and let it be free of stress there. In our hopes that it's going to pull it just a little bit into alignment. While I'm using that thing, got this right here. We got the bolts loose anyway. I'm gonna let it cool now. All right, I feel pretty good about the braze that I got there on top. Got to dab it in there, make it look nice too. I did get a little bit of fall through on the bottom. That's okay. We're gonna make sure we do the bottom there as well. So I'm gonna let this cool. And then once it's cool, I'm gonna take it off the fixture and then I'm gonna start building up the sides. And then once we do that, we'll check and see how flat it is. I think it's gonna be pretty good. It's the next morning. We've got our casting nice and cool. I brought it over here to the surface plate and did some inspection on it. And it did show that it drew a little bit more than what I was hoping that it would. But our shim technique did work on there. So it should have just had a little bit thicker shim. When I brought it over here, it had just a very slight amount of gap on either corner right there, meaning that it was actually a little high right here in the center where our joint is at. So what I did is I just took this C-clamp and pulled it back together, and now it is sitting nice and flat here on the surface plate. It's about as flat as I can get it in its natural state, just like it is. All right, so it's sitting there good, no rocking at all. I'm going to use the C-clamp to continue holding it together while we get the two sides brazed in. And once we get those and hold that, we'll take the C-clamp off, and I think that's where it's going to be. All right, so I'm going to go ahead and get back to some brazing, continue on with it. Okay, we got her set up here. I got it clamped to an angle plate with some fire brick around it, kind of help absorb some of that downward heat. And I'm just going to go ahead and get it preheated again. Got the short rods all brazed together so we can use up the leftover pieces. Got it hot and we are ready to go. trying to get that built up without it rolling over, falling off. Seeing that? think I reached to the end of the brazing procedure here. I've got it all the way around, and I'll continue to go around and touch up the flat sides as I need. We've got that. That was probably the most challenging, is getting down inside there. That's usually pretty tricky, but I've got it to all flow together. You know, it may not be the prettiest looking uniform beads in there, but I've got it all flown in there and it's bonded like it should. We've got that area built up on that little ear that's got to be shaped and drilled and tapped there. So I'm happy with it. I think it's gonna turn out to work out once we get it all cleaned up and get it machined. I think it's gonna be good. So I'm gonna let this guy cool down for a while and come back later and get back on it.